So cloud applications monitoring is a down-to-earth concept which involves a lot of human resources, manual tasks, and administrative tasks to be performed. But Applications Manager provides you with cloud monitoring functionalities to achieve such goals and to ease the process. Let us have a quick look at the agenda. First up, we will be seeing key insights for the AWS admin, followed by maximizing efficiency of Microsoft Azure applications. And then we will discuss how Office 365's performance metrics are monitored. And lastly, we will see effective resource planning tips for cloud monitors. So talking about the cloud applications, we have various monitor types available in Applications Manager. And the commonly used cloud applications being Amazon, Microsoft Azure, and Office 365. So each and individual service has multiple services being monitored well within them, which is what we will be seeing. Since Applications Manager is an agentless monitoring tool, we use various protocols to connect to the target machines and collect these metrics. So similarly, these cloud monitors also require certain prerequisites to be completed. As we see, AWS monitors require the AWS access key and the secret access key for the monitor to be added and performance metrics are identified. Next, we have Office 365, where an account that is being handled should be a member of an Office 365 admin role. And lastly, in Microsoft Azure, PowerShell scripts or remote PowerShell scripts should be enabled to collect data. Now let us quickly get into the AWS monitor. So as we see, for every business unit, maintaining the status and efficiency of the cloud resource is a picture at a higher level. It is also important to know the status of the resources available well within the AWS network. So we will be seeing the key metrics that are important while monitoring the business critical cloud applications. Now this is the Amazon Web Services architecture, where we list out various monitor types like the Elastic Compute Cloud Instance, the Load Balancer, Dynamo Database, S3 buckets, so on, so forth. In order to get metrics for all these instances or all these services, there are various API calls which are being used to fetch the data from Amazon CloudWatch and publish the same in Applications Manager UI. So we will also be seeing how root cause of performance issues across AWS monitoring is done, apart from all the services which are identified. To begin with, let us discuss the EC2 CPU utilization. So the EC2 CPU utilization is an OS level metric which is essential to identify the current CPU usage. Along with it, there are other critical metrics like the disk read-write operations, which is also required to identify the number of connections or operations which are being taken place in a specific instance. Now in the EC2 instance, we also monitor the network traffic. The reason being, this network traffic lets an admin identify how well the traffic is being distributed across each and individual instance in order to ensure that optimal network speed is available across all the services. Now next in AWS, we have the relational database service. So this is a distributed relational database service, which is a web service running in the cloud designed to simplify the setup, operation, and scaling of relational database for use in various applications. So RDS supports an array of DB engines to store and organize data, and it also helps the user identify various database management tasks such as migration, backup, recovery, and patching. Now, while these operations are being performed on the database, there are various connections which are being identified in the background. So this becomes a key metric where database connections is monitored, and at the same time, the storage is also kept in mind. The reason being, the more amount of free storage available in a database helps the user allocate more resources or perform more operations. Now, in the database, when any operation is being performed, be it a read operation or be it a write operation, there would be monitoring of latency that is essential. So this is what we identify in Applications Manager, where the read latency as well as the write latency is identified per every second. So this includes the total time taken for the database to perform the input-output operations. Next, we have the read-write capacity units. So this is under the Dynamo database, where there might be many operations which are running in the background. So while these operations are running, we have identified the read-write capacity units, and it is identified as provisioned read as well as provisioned write, consumed read and consumed write. Now, while these operations are being performed, there are various latency requests which are identified, and these are split up as 4 different performance metrics, and these include get latency, batch get, scan, and lastly we have query. So these are some of the key metrics with which a user can identify the number of latency requests well within a single Dynamo database. Up next, we will see Amazon Simple Notification Service. So this helps a user identify the overall message throughput and the total number of messages that have been published per KB per hour. Added to this, we also monitor the overall messages that have been published, and for whichever message that has been published, a notification would have been delivered. And at the same time, there would be certain notifications which would have failed. And we determine all this information along with the published size of each and individual message. Next, we have the AWS Billing, which is one of the widely used aspect or service in Amazon Web Service. The reason being, this lets a user identify how is the cost that is being spread across various services available within AWS. So as we see here on the screenshot, there are many services, out of which few services are using more, while on the other hand, there are a couple of services which has a zero utilization. So this way, an admin can effectively identify and also at the same time distribute resources to those that are being occupied and used at the maximum. Now, in the AWS Monitor, we also have a load balancer, which is more like a clustered environment where we have various resources like network-based load balancer as well as application-based load balancer. So what we see here in the screenshot is an application-based load balancer where there might be multiple targets which are assigned within a single ALB or an application load balancer, and these targets are grouped in a single target group which has its own unique ID, and it lets the user identify the number of errors, which is a load balancer errors, and at the same time the reason of each and individual load balancer. With that being said, let us get to the UI and see how product works across these monitors. I go to the Monitors tab and navigate to the bottom where we see Cloud Applications, under which I click on Amazon, which lists out various services which we saw in the screenshots a while ago. So let me quickly take you to one of the existing EC2 instances. So this specific EC2 instance helps an admin identify the CPU utilization, the network traffic, as well as the disk IO operations. So these are the common overview metrics. But as we proceed further, we have more information across these OS level metrics where we identify in-depth usage of the available memory, which is the total memory that has been allocated to an individual instance, and at the same time we also identify the total number of bytes that have been in use. So down below, as we see, we identify the disk utilization, which is across the number of disks which are present in this specific instance. And at the same time, it also gives a graphical data across various time frames, letting know if there is a spike in the utilization of the disk. Now next is the attached volumes. So in the EC2 instance, there might be various volumes which have been attached, and at the same time, these volumes have a unique volume ID, and the volumes will also have an associated space which is identified in size, which is GB, and it also helps a user identify when exactly a specific volume was attached and what is its creation time and for how long it has been idle. So the same information is what we identify here in the graph. And further down below, we also perform the read-write latency operations on the specific volume ID, where we can see the overall idle time along with its bandwidth to let an admin identify the usage of various metrics. Now, the utilization might change from time to time, and it might not be an easy task to keep a regular eye on these metrics. So instead of that, Applications Manager has provided an option where Configure Alarms lets a user provide a user-specified threshold, which helps any user identify whenever there is a breach in the threshold, with which an immediate action can be taken to ensure the performance is well optimized back again. Now let us discuss the other instances as well. So this is the RDS, which is the relational database. So since this being a database, we monitor the CPU utilization as well as the storage. Now moving further, we have more information for the input-output operations. So there might be various queries running or various requests which are being sent to a specific operation to be performed in the database. So once these operations are being executed, it has the throughput as well as the latency which is available. So we track these information to help a user identify if there is any spike or if there is any change in the throughput or if there is any change in the latency, which identifies the number of requests, and these latency include the read-write latencies. Similarly, we also monitor the network traffic, which is the total incoming as well as the outgoing traffic, such that a user can easily ensure that network is evenly split without any hazards. Now let us discuss the S3 buckets, which gives an overview of all the buckets which are available well within a specific AWS. Since AWS has two different regions, one is the global, the other one being China. So as we see, if a user chooses global, it helps a user identify the buckets from various locations which can be spread across the globe. And each bucket might have its own virtual folder along with the number of objects. And that is what we monitor under the S3 buckets. Next is the SNS, which is the simple notification service, which helps users keep track of the number of messages that are being published and the number of notifications that are delivered, as well as notifications that are failed. So we have more granularity towards the SNS, which is we identify the delivery rate ratio as well as the failure rate for the messages that are to be published. And at the same time, we also identify the region-wise metrics for each and individual region to let a user identify the number of messages that are being published. And it also helps a user calculate or keep track of the month-to-date charges per SMS, which is the message. Now let us have a quick look at the Dynamo database. So Dynamo database, as the name suggests, is a relational database once again where the read-write operations are being performed, and we capture all these read-write operations individually, where monitoring of the latency, which is spread across the get, batch get, scan, as well as the query. And all these information is split individually across the read as well as the write operations, which helps a user not just track the current utilization, but also with the historical reports, any admin or any user can identify how well or what exactly is the read operation or the write operation across various time frames. Now, for any action that is being taken in the database, there might be certain errors which might just occur. And these errors might be a user-related error or a system error, or maybe any condition that has been provided for a specific operation to be performed, or any deleted item. Now let us get to the next aspect or next service in AWS, which is the load balancer. So as we saw a while ago in the screenshots, the load balancer helps a user identify their clustered environments where the number of requests that are being sent to a specific ALB or network load balancer can be identified, and the total requests per minute is also identified. And at the same time, we can monitor the number of active connections and the number of new connections that is being constantly trying to hit a single load balancer. So besides these, we also monitor the process bytes, which helps monitoring of the total amount of data that is processed, which is for every minute, and any specific rule evaluations. Now the load balancer might have various target groups where a group of targets are assigned to a specific group with a unique ID, and these target groups are accessed over secure or non-secure protocols, and the total time taken for the page to be hit is what we monitor under timeout in seconds. Now each target group might have various targets, and these targets are identified as healthy or unhealthy hosts. So the amount of information that we see is identified down below, where a user can easily get to know information about various HTTP response code. For instance, a specific load balancer is unaccessible. At that point of time, a user can identify what could be the reason, be it a 5xx error or be it 4xx or whichever it may be. And at the same time, it identifies the number of healthy targets as well as unhealthy targets, and it lets a user keep track of things. Lastly, we have the AWS billing. Under the billing, an admin, as we see on the screen, can identify the total expenditure of the services that are being utilized. And at the same time, an admin can also keep track of the overall tax and the services which are being utilized, which is the cost per service per month. Now, as we see, this graph gives an overview of the month to date top services by spend, wherein the same amount of information is also available on the graph, where a user can create a threshold to ensure that the cost will not exceed a specific set threshold. And on the other hand, if a specific service is not required for monitoring, a user can check one of these options and click on either disable or delete, which will only perform the operations on Applications Manager UI. Now let us go ahead and see the other cloud monitoring, which is Microsoft Azure. Microsoft Azure provides a range of cloud services, including those for compute, analytics, storage, and networking. So as we see, Microsoft Azure is spread across three different factors or three different services, and they being the virtual machines, storage accounts, as well as SQL databases. So the Azure monitoring, besides having an overview of these three different services, we will also see how the metrics can be calculated, which is the critical metrics, and how these instances can be diagnosed. So this screenshot gives us an information across all the Azure resources, which is the total number of VMs which are provisioned, the total number of virtual machines which are running, the storage accounts, be it standard or be it premium, and lastly, we will see Azure SQL database. Talking about a virtual machine, it is highly essential that the memory utilization is constantly monitored, and memory utilization in Azure VM includes committed memory as well as the available free memory. Besides this, we will also monitor the disk metrics to help a user identify the number of disk read-write operations that are being performed at any given time interval. And lastly, we also monitor the network traffic, which is an essential metric to identify the network interface health, where there might be multiple network interfaces available within a single VM, and each and individual VM might have various NICs where the traffic might differ, and at the same time, if there is any error identified, the same is also notified, be it an inbound error or be it an outbound error. A VM also has various processes as well as threads which are actively running in the background. Now, it might be a tedious task to go to the individual VM to take a list of all these processes as well as the threads. But whereas this specific monitor type helps a user identify the number of processes which are running in the background, and at the same time the overall processor time, followed by the number of threads, be it an active thread or be it a daemon thread. Last but not the least in the VM is the command language runtime. So this helps a user identify the overall JIT compilation time, followed by any remote calls or any exceptions while performing any operation. Now, before we see these metrics on the UI, let us also discuss other available services under Microsoft Azure, which is the storage capability, where metrics are spread across 4 different performance metrics. And these includes the blob, which is the stored data in a binary form in the database. So this is what a blob is, and we also have more details about the blobs as we will be seeing on the UI. Next, we have the table. So the Microsoft Azure stores a large amount of structured data, and that is what is monitored under the tables availability, followed by the queues, where it stores messages that can be accessed over HTTP as well as HTTP calls. And lastly, we have the file availability, which is pretty much similar to a file sharing that uses SMB3 protocol. Now let us have a quick overview of what the storage account is capable of. So as we see, the storage latency is monitored, which helps the user identify or keep track of the blob's end-to-end latency as well as the server related latency. And also at the same time, we monitor the throughput, where some of the key performance metrics include the total ingress, the total egress, and the number of requests which are being sent for the blobs, followed by the collection time as well as the billable requests. Now, while monitoring the blobs, there might be any throttling errors which could be a possibility. So we also monitor the same, where there are various types of throttles whenever a blob is overused. So we identify such throttling errors, which is an authenticated, unauthenticated, and any failed API calls. Now, with that being said, let us move to the SQL DB, which is the database transaction unit. It is a blended measure of the CPU, memory, as well as the data input-output operations, which is determined by an OLTP benchmark. So the Azure SQL database has various performance metrics that are available for monitoring. And these metrics are identified over a graph where we monitor the OLTP stored usage %, followed by the number of concurrent requests and the active sessions which are currently being used, followed by the number of database connections, be it a secure connection, successful connection, or a failed connection. Now let us get to the UI to see how Microsoft Azure Monitoring works. We go to the Monitors tab again and navigate to the bottom under Cloud Applications. We find Microsoft Azure, where it lists out the overall resource value, which is the resource allocation, to identify the provisioned VMs as well as the running VMs, followed by the standard or premium storage accounts and the Azure SQL databases. Now let us have a deeper insight into each one of these existing services. So let me begin with the Azure Virtual Machine. where the common metrics is the CPU utilization as well as the memory utilization, which is spread or which is distributed as physical memory, swap memory, and the free physical memory. Now, moving further, we have individual tabs to help a user monitor all these metrics in detail. So as we see under the CPU utilization, we identify the processor metrics where a user can identify the overall privilege time as well as a user time followed by the processor frequency. Now, similarly, under the memory, we monitor the committed versus the available memory, wherein in simple terms, we monitor the respective used memory as well as the free memory that is available for a specific VM, followed by monitoring of the pool page versus non-pool page, which is the DB operations or any operations which is being run in the virtual machine. So the virtual machine also has various disks which are attached to it, and each disk might have its own size, and that is what we monitor, followed by the read-write operations, which is a key metric. Now, if a situation arises, if one of the disks is not required for monitoring, so a user can choose one among these three or any available disks, and from the actions drop-down, a user can choose to disable, enable, or delete one of these operations, which will only impact monitoring on the UI, but not the original instance. So next is the network. As we see, we monitor the TCP connections, where monitoring of the number of connections which are established as well as failed, and pretty much similar to segments as well. So number of segments that have been sent or received, which is the packets. And we also monitor the command language runtime threads and its individual stats, where we identify the remote calls per second, the exceptions, as well as the overall queue length. Now, under Microsoft Azure, the storage accounts has various metrics like the blobs, tables, queues, and files. So these blobs have intricate monitoring where we can monitor the overall capacity that is assigned to an individual blob, and at the same time the ingress or the egress operations, which is identified under the throughput, is also seen, followed by the latency, which is the number of requests that is being sent to the blob. And lastly, we monitor the number of throttling errors. So these errors include authenticated, unauthenticated, failed API calls. And the same metrics are pretty much available across all the file, queue, as well as tables. Now, monitoring of the storage accounts also involves in monitoring the network related information. The reason being, any timeout errors or any failed requests result in the blob being inaccessible. So in order to ensure that these metrics are accessed without any hassle, we can identify the blob's information, which is either the client timeout errors or the failed API calls errors or the overall percentage of the failed timeout errors. Last but not the least, under Microsoft Azure is the SQL database. So since this being a SQL database, there are various performance metrics which are monitored. But before that, the overview includes monitoring of various resource utilization, which is the DTU and the CPU utilization. Now moving further, we have top queries by CPU, which will be predominantly an essential business critical metric. The reason being, any queries which is taking more time to execute or queries that are being constantly utilized might have a performance bottleneck and impact the performance of the database. So in order to ensure that these queries are well optimized, a user can identify across various performance metrics, which is like the top queries by CPU, top slow running queries, or most blocked queries, or frequently executed queries. Now, across all these options, a user can set a unique threshold to identify if there is any change seen across the databases. Now, let us move to the last cloud monitor for today's webinar, which is the Office 365. So Office 365 has 3 different services available for monitoring, and these being Exchange Online, SharePoint Online, and Skype for Business, which is Microsoft Link. Under Office 365, we monitor the total license count as well as the assigned license plan, be it an enterprise plan or a premium plan. Whichever the information is, the same can be identified on the Applications Manager UI, followed by other metrics like the total license count, consumed license, warning units, or suspended units. So besides these, we also monitor the health and connectivity of various services available within the Office 365. So as we see, each and individual service is connected on its own endpoint. And if the endpoint is down, the specific service might not be accessed, which results in a heavy downtime where either of these services will not be functionable. The first service in Office 365 being the Exchange Online, where we monitor the services under the Exchange server, which is the delivery rate or the management provisioning of the Exchange service, followed by the Mailbox, where we identify the overall amount of mailboxes which are available for monitoring, and at the same time any unused mailbox is also monitored. So as we move further ahead to the other service, which is SharePoint Health, as well as the number of resources available within this. Now, since this being an online service, this specific SharePoint can be accessed over an individual URL, which has its own storage capability or storage which is assigned, followed by the number of resources present well within an individual URL. And once again, we monitor the number of services as well as its endpoint connectivity, followed by the files or documents that are present within a single URL. Now, while monitoring the SharePoint services, it is also essential to monitor the errors. These might be an installation related errors or runtime errors or maybe any upgrade errors. So in order to ensure that all these applications, which is the files or folders which are constantly accessed globally, which is public or private, it is essential that these metrics are monitored constantly. Next, we have Skype Online. So since Skype is a business feature or a business option which encompasses features like the instant messaging, voice call, video call, screen sharing of devices. So these are some of the critical services which are to be monitored such that an impact on any one of these services results in the failure of these operations to be performed. Now let us go ahead and have a quick overview in the UI to see how monitoring of Office 365 works. We go to the Monitors tab, and under Cloud Applications, we have Office 365, where the primary information that is being monitored is the license details. So as we see, this gives a user an idea about the total number of licenses which are available, the licenses which are being currently used, and those that are being unlicensed or warning. Warning includes a license that is about to expire with a 30-day grace period that is being monitored, followed by a suspended unit which is beyond its expiry date, and unassigned licenses, those that are ideal. Down below, we also monitor the service health of each and individual service which is available within a Microsoft Office 365. The first important service is the Exchange Online, where we monitor the endpoints as well as the service health. So this lets a user access multiple endpoints, which is either the Outlook or the email connectivity, so as to send emails or communication is done with ease. Besides monitoring the endpoints as well as the service health, the important metric is the mailbox. So as we see here, this specific mailbox might have a size associated, be it 30 MB or be it 50 MB. And at the same time, we also monitor the number of emails which are available. So if the size goes beyond the set limit, new emails might not be received. So in order to ensure that this does not cross the limit, monitoring of mailboxes is done, where thresholds can also be configured with the help of the configure alarms option. And next, we also have the inactive mailbox users. So if there are multiple mailboxes available, out of which one or two or maybe more than that are not being used, so that information is also what is being tracked, and we will publish the same information on the UI. Next, we have the SharePoint service, where we monitor the various tenants which are available, as well as its endpoints once again, where accessing of the files is done over various URLs. So as we see, there are various features available within a single SharePoint, which gives more information across monitoring of the site's URL, the space that has been assigned to an individual site so that files can be accessed or new files can be provided. And at the same time, the file name as well as its errors are also being monitored, which is the install related errors, runtime, as well as upgrade errors. And lastly, in Office 365, we have Skype for Business or Microsoft Link, where monitoring of various services, which is the voice call service, the instant message service, or the screen sharing session service. So all these services are constantly monitored all the time to ensure that these services are up and running without any issue. So similarly, we also monitor the endpoints as well, where the response time is calculated and the port on which a specific application is accessible is identified, along with the status of each and individual service. Now, with that being said, let us move to the last part, which is effective resource planning for cloud applications. Now, forecasting helps IT enterprises to predict future disk utilization, which is based on current utilization trends and also balance hardware costs with computing needs, where an admin can stay informed about current usage trends or even plan future requirement based on the forecast reports. Now, in an ideal IT environment, there might be various services which are available. And out of these various services or servers, it might not be a viable option for an IT admin to track how well the resources are being utilized across various timeframes, be it 5 months down the lane or be it 1 year down the lane. So in order to ease this, Applications Manager has bought the feature where a user can predict the disk utilization with the help of the report, the forecast report, where machine learning helps a user get accurate results. So what we see here on the screen is an overview of when exactly the utilization will go to its maximum potential. So if we click on an individual disk, provided there are more number of disks, the utilization will be easily identified across each and individual disk. So the moment a user clicks on an individual disk or an individual metric which is spread across all the cloud applications, this gives the user more granularity, letting a user identify what was the utilization over the past few days, and with the help of the enabled machine learning, it compares the trend and it predicts a forecast information, letting everyone identify what will be the utilization at a specific date at a specific time. Now let us go ahead and quickly see the same option in the UI to see how reports can be captured. To enable reporting for the cloud applications, it is essential that a user has to go to the reports tab and click on enable reports. So once we click on enable, it lets user navigate between the existing options. So cloud applications is one of the option where a user can choose one of the individual monitor, and one of these metrics or multiple metrics can be enabled for reporting, where Once this is enabled, forecasting or resource planning can be done with the help of these options. Now we are back in the reports tab, and as we scroll to the bottom, we have the forecast report option. So this forecast report is spread across various servers. Since cloud applications has more services like the EC2, the RDS, S3 buckets, or Microsoft Azure, Office 365 for that matter, a user can identify the current utilization trends and get a report of the future utilization. So as we see, there are various metrics which are enabled, and at the same time, these metrics can also be disabled so that reports can be accessed. Now let me choose one of the metrics, which is the CPU utilization for the EC2 instance. Now as we see, we can compare or create a value which is spread across the last 3 months or last 1 year and choose a distinctive time interval which can be 5 months, 6 months, anything like that. Now once machine learning is enabled, Applications Manager predicts the utilization of a specific attribute or a performance metric that is chosen by the user, and it gives tabular information. To get more insights into the utilization, a user can click on one of these options. Let me choose the first available monitor, and as we see, it has a sudden decrease in the utilization in the month of May, and then it has been gradually functioning across May as well as till the current dates. But the future utilization or the future forecast mentions that there is going to be a gradual or drastic increase in the utilization of a specific monitor. And to get more information, we can identify what will the utilization be across various time intervals. So as we see here, 7th June, it states that the utilization is going to be 19.6. So similarly, moving further down, the utilization value changes based on the trends. So this is how a user can easily keep track of their resources with the help of effective resource planning. Now with that being said, let us have a quick recap of what we saw today. First up, we discussed about various resources of AWS, and these being the RDS, S3 buckets, SNS, billing, as well as the load balancers. We had in-depth analysis of how monitoring is done across Microsoft Azure and its various resources like the storage accounts, virtual machines, and the SQL database. We also saw how Office 365 monitoring is done across the Sharepoint, Exchange, as well as Skype. And lastly, we did discuss how resource planning can be done with the help of the forecast reports.